This
That's not bad. I kind of like Beulah.
it started to stick with me after a while. And at the moment it's plastered across the side of her, so she's still technically Beulah May right now. But
All right, well, welcome folks. We will go ahead and get started. So my name is Scott with Offsite Dirt. Audrey Grabesic is currently out dealing with some modular projects. So she's out in the field, and unfortunately the flight was just had to be right now. So I'll be with you guys here today. So welcome to this month's panel, Principles of Offsite Construction Building Techniques. So Offsite Dirt, if you're not familiar, is a media and event company and showcases all the current news, techniques, technology, influencers, and conversations in offsite construction. This form of construction encompasses volumetric, modular, prefab, panelization, and single and or multi-trade assemblies. So obviously there's a lot happening in the industry right now. There's a lot of change, a lot of dramatic change taking place, a lot of homes that need to be built and not enough people to build them and not enough resources. And so we wanted to take a minute to dive into some of the design build systems that are out there that are using prefab and other forms of offsite construction to really dive in their systems and see how they're reducing waste, reducing time, and just creating projects that in the end are just better for the planet and better for our health than traditional stick-built construction. So today we are joined with leaders from EMU Systems, from Public Prefab, and from Collective Carpentry, as well as Elevated Design Build. So just before we start, feel free to say hi in the chat feature, say who you are, what you do for a living. You know, feel free to put your LinkedIn or your website to your company. This is an opportunity for everyone to connect and to meet each other. And yeah, and then also ask questions. Feel free to ask any questions in the chat feature throughout the entirety of the panel. And towards the end, we will have a Q&A where we will choose some of those questions and get some answers from the panel. So with that, we will begin, and I will introduce our panelists. So to start with, we have Mariana Pickering, co-founder of EMU Systems, and she is a recovering architect and expert in communicating the construction industry's movement towards a better understanding of building science and sustainability. With over a decade of work on high performance projects and products across 3 continents, she is passionate about translating data, results, and needs into stories that help shift the cultures and mentalities of building professionals towards change. Past experience includes working with Bill Becker on the 2016 Presidential Climate Action Plan, 2017 founding member of the Passive House Rocky Mountains, elected as the 2018 and 19 chair of the Denver chapter of the Colorado Renewable Energy Society. And she currently manages strategic partnerships and the licensing of EMU's certified passive house tradesperson curriculum, organizes the Colorado Passive House Happy Hour, and makes the wheels turn at EMU. So welcome, Mariana. We are excited to have you.
thank you very much.
Next is Jan Pratschke with Collective Carpentry. So Jan oversees the design process and all the production of the 3D models, shop drawings, cut lists, and install drawings for the shop and install teams at Collective Carpentry. He brings a timber framing and business background to his work at Collective Carpentry and is equally at home in front of a computer or on the job site. Welcome, Jan. We're excited to have you.
Thank you.
Up next is Edie Dillman. Edie Dillman, the CEO and co-founder of B Public Prefab, is a decidedly disruptive company committed to systems changes that accelerate sustainable solutions for housing development. She is a proven leader of creative and business teams from architecture studios, graphic design to magazine publishing within a mix of companies across nonprofit, government, and the private sectors. In her previous work at Innovate plus Educate, she worked nationally to shift to skills-based education and employment in the critical change for equitable workforce pathways. Her co-founding of B Public came directly from the intersection of her work in addressing the workforce skills gaps and the development of standardized offsite construction system from her co-founder's design practice to meet the demand for high-performance construction in markets with serious skilled labor shortages. Welcome, Edie, to the panel.
Thanks, Scott.
And last but not least, we have David Kaplan from Elevated Design Build, General Manager, Lead Designer, and Hands-on Builder. So David has had a career in design and construction, seemed destined from a young age. He building tree forts, constantly drawing and sketching, and eventually landing his first real job, sweeping floors for a large civil contractor in Salt Lake City. His interest in the built environment blossomed in college while studying at the University of Washington, where he focused on sustainable design and design build practices. His first job after school was with a design build timber frame company in Washington State, where Dave says timber framing found him. Since that time, he has been involved in hundreds of timber frame projects throughout the United States and a few internationally. Dave founded Elevate Design Build in 2015 with the intent of creating inspiring, healthy homes for their clients and providing a meaningful, rewarding career for his colleagues. When not nerding out on design and construction, Dave loves traveling and experiencing other cultures, mostly for the food. Welcome, David,
Howdy.
to the panel.
Thanks, Scott.
So we will dive right into the questions, and this first question will also give each of our panelists an opportunity in their own words to dive into the background of what their company does and how they're helping to drive our industry forward. So question number one, pretty straightforward. What are the main differences between your building system and traditional construction? So our first panelist to answer that will be Mariana.
Well, hi there. So first of all, I'm super excited to be here. The other panelists on this are all people I've known from the industry, from Passive House Connections before. And so really great to see everybody here talking specifically about prefab. You know, our company and my entire kind of career lately has been really focused on the Passive House Building Standard, which I'll mention in a second. But the most exciting thing to see is how that high performance building science can interact with concepts like prefab and modular that make it you know, more cost effective to actually apply high performance. So yeah, so my company EMU, you know, we're really focused on taking research, building science, most up-to-date kind of science-based information you can find about products and how they perform, and then applying that to construction systems, to products, to projects, and we also certify people. We educate people on builders on the Certified Passive House Tradesperson accreditation. Passive House, for those of you who don't know, I'm looking at the audience list and I recognize a few faces, but for those who don't know, the Passive House Building Standard is, I describe it as the building code of the future. It's not necessarily a certification checklist like LEED or Living Building or things like that. It's more like a building code metric, performance metrics based building code. So the slide that's showing right now is kind of the go-to image to describe what Passive House does. You look at the thermos versus the coffee pot that's on a continuous source of energy. And what we're trying to do is conserve as much as possible before compensating through a very tight building envelope, basically. So there was something else I was going to say about that, but you're good. So, no, you're fine. So anyway, so what we focus on is part of our business. Like I said, we do the training, the certified training for builders to be able to learn how to apply this building standard to what they're doing. The other side of our business, we're really passionate about ways to simplify and standardize that. So we do everything from component certification. So we work with manufacturers like the other folks here to help them certify their panels for the Passive House Building Standard. And then we also have a construction system that's really more of a collection of details and junctions that we license out to builders with instructables and instruction videos on kind of how to then apply that. And so part of that involves a whole bunch of different high performance products, including some of these panels that you see from some of our colleagues here. What's the next slide I have up there, Scott? So, yep, and even in our consulting work and in our in the standardized construction systems work that we do, we're always education first. I'm the daughter of two teachers. We're both very Enrico, my co-founder, we both have always had an education first mentality, and I think you'll find a really big overlap with most of the Passive House community in wanting to be open-minded and learn new ways to apply these things. That's a picture from one of our workshops. Okay. And then, yeah, the last one, we're just saying, the virtual prototyping aspect is what's important to us. So I think one of the biggest takeaways from those who get into the Passive House Building Standard, or really any level of building science education, is that you realize that there has to be a shift in your attention on the design construction stream. You've got to pull a lot more construction knowledge and information up to the front end in the design phase, which is basically what all of these folks are doing as well. We become product designers and not necessarily just builders, and being able to present that product in a complete form is really the key to implementing building science. That's a picture of our pod. So I've obviously remembered all of the slides that I've given Scott here, but our training and education. So one of the things we try to do is really take that research and the building science education and try to make it as hands-on as possible. I think in the construction industry, we're pretty used to having kind of manufacturer sponsored educational content in the form of kind of, traditional wall mock-ups or product demos and things like that. We've really tried to push past that. We wrote the curriculum for the North American Passive House Tradesperson certificate, and we teach that in a course setting, both online and in person. But the workshop is really where we kind of extend those learning objectives into hands-on format. So we have this pod called the Passive Pod, and you break up into teams during the workshop, and everybody gets together, and each kind of panel or piece of the pod addresses a different lesson corresponding with our curriculum. So thermal bridges, or high performance window installation, or the mechanicals, or something like that. So we also cover job role simulation. I think these guys will tell you too, one of the advantages to prefab and offsite is that you have much more quality control. And when you're on site, that the job roles of where scopes overlap and who is doing what on your crew becomes all the more important, especially because sequencing is so important for building science to be applied appropriately on site. So we try to simulate that in the training as well. Do I have another slide, Scott?
I think that was it, Mariana.
Right.
So thank you for that introduction. And now we will move on to Yan with Collective Carpentry.
Nice. Thanks, Scott and Jacob and everyone else for being here. It's a real pleasure to chat with you all. So yeah, maybe I'll just kind of give you a little bit of an introduction to the company, and then kind of get to some of those questions about the main differences between our system and traditional construction. So Collective Carpentry has been a general contractor, or was a general contractor from 2014. And back then from 2007, 2006, 2007, building high performance homes. And then in 2014, we moved the operation indoors. And a big part of that really was, it was not necessarily that we thought, prefab was going to be the be all and end all of construction. And it's certainly, there's obviously a lot of movement towards prefab in the industry today. But for us, when we started, it was really a reaction to just being outside in the cold and just kind of feeling like it's just not a sustainable thing for our bodies to be, hanging off a ladder, hanging off scaffold in a good old Southeast British Columbia winter. And some of it is just our own, wanting to keep ourselves indoors, keep our tools indoors. But also one of the striking things about high performance building is the cost of the materials that you use, of course. And a lot of the cost as well is in importing the materials and storing the materials, and some of the time it takes to source materials and keep them. So we found that we were just, working with extra layers, thicker walls, more layers, more membranes, tapes, insulation, all these different products that, some of them just can't really be applied effectively at, minus 20 or minus 15 Celsius. So working indoors was just something that we thought really moving towards working indoors really honored not only our bodies and our tools and the other people that we worked with, but also the cost of materials that we were working with, and ultimately our clients' budgets. So we looked to Europe for some inspiration and found, a bunch of companies in Europe who've, some of them have been around since the dawn of time, and it's 20th generation carpenters from Europe who are now operating. That's a bit of a stretch probably, but fourth generation carpenters in Europe who are now operating in prefab shops that 80 years ago were traditionally timber framing, and now are operating with some fairly sophisticated machinery to produce many houses, sometimes hundreds, sometimes thousands. So we don't necessarily look to that that quantity of production, but certainly gain some inspiration from some of those businesses that have been around for quite some time, and that are contributing members of their communities. So we moved indoors, 2014, and since 2014, so this will be our 7th year of operation, and we've done about 32 projects, I think. Not all certified passive house, but definitely that's where our passions would lie. Everything we do is how we describe sometimes just sort of passive house, certifiable, meaning everything is going to be airtight. We use all of our tools and techniques and parts to try to make things as airtight as possible. We, as a supplier to contractors and architects, we don't always have a say over whether or not something's going to end up being a certified passive house, or what energy level it's going to be, because we don't have control over things like site orientation, or sometimes quality of windows and doors, or the effectiveness of a mechanical system installation. We don't know those things, but what we do know is how to build things airtight. So everything that leaves our shop is airtight. Most things that leave our shop are going to be climate appropriately insulated. So, we do have a say. If somebody says, hey, I want to build this wall and, it's in Whistler, I'll say, well, I think you could increase the level of insulation, and I could show you a bit of a value proposition for why you might want to do that. So most of the things are climate appropriate, appropriate levels of insulation for certain areas. I would say about half of them end up being certified passive house, which is a pretty good record given the difficulty of actually achieving passive house certification in a lot of places. So we're definitely proud of that. There's a couple of pictures of our shop. So the shop is, it's a fairly modest size shop compared to lots of other operations, the ones we kind of look to on all over North America and all over Europe. But we're proud of what we build in that little shop. We've built a lot of quality homes. We've built some really difficult projects. We don't always look back with fond hearts of all the difficulties we've had, but we've come about our experience honestly, and we definitely have built some interesting buildings that one of which there's a photo I think a little later of a passive house certified church, which is up north of Fort St. John, BC. So it's about halfway up BC. It feels like it's further than that, but we installed this church in the middle of a nasty winter a couple of years ago, and now it's finally been finished, and it has achieved FIAS certification. So that's one of those projects that we're really proud of. So some of the benefits, or maybe I could talk about the differences between our system and traditional construction. So a big benefit of prefab would be, like I described, just having some control over the quality of your materials and having the ability to keep those materials stored inside and working them at the correct temperature, for example, with tapes and membranes and caulking and things like that. The other one would be simultaneous construction. So we're building panels in the shop when a site is being prepared. So it's a pretty nice thing to know that you can finish a foundation and we can be there a week later ready to put panels up. And really, when a contractor is building the foundation, they really do need to be thinking about the next steps after we leave, because we come and go pretty quickly. The average install timeline would be about a week, where we'll come in, have 2, 3, 4 days of crane time, and then a few days of wrapping up all the airtight detailing, structural connections, things like that. So it really does happen fast. That would also be probably a good way to talk about some of the struggles. One of the struggles that we have is that we're trying to ask our stakeholders to make all of the decisions early on in production. So because we build inside, we need to use 3D modeling software to build the whole building, everything certainly that we're going to produce, in order to make shop drawings to get this thing into the shop. So one of my biggest struggles, like every day, my biggest struggles is trying to get people to finalize things, you know, trying to get people to sign off on drawings and choose that last window size, because we really do need things to be, you know, pretty complete in the planning phase before we can build. So, you know, there are pros and cons, and one of the planning hurdles is definitely that you're asking a lot of people to sort of change the normal course of planning activities and make decisions early. So that's been a challenge. That is a challenge for us. And on the plus side, though, having forced people to see things through and to fully think through their building, we now have a fully finished 3D model that we can use to think about collisions between mechanical, electrical, plumbing, really try to optimize the materials that we use, reduce the amount of redundancy in materials. So for all the, you know, there's some pros, there's some cons, but in general, I think despite the difficulties, we can end up with a really high quality product that's delivered faster. So I don't claim that prefab is better than site building, but I do claim that it's easier to build high performance in a prefab environment. I think a lot of great houses are being built on site, but the weather is not helping. It can work out just fine through perseverance, and a great quality product can be built on site. But for us, we found that we can deliver higher quality in this environment, where we choose the layout of the shop, and we choose the temperature to some extent. Yeah, so there's a few different images, just a couple of projects. One of the questions that Scott asked was, you know, highlighting projects. One of the things we're proud of is delivering projects to difficult places and just being able to persevere. So we have a really talented install crew in the States, and a really talented shop crew and install crew up in Canada as well. And we have delivered to some pretty remote places in, you know, and often in the winter weather as well. So it's not necessarily like a logistical planning success necessarily. It's often just through perseverance and refusal to quit, you know. And I would say that's one of the characteristics that we share in our crew.
And probably the whole construction industry that's doing it right, at least. So thank you, Jan.
Yeah, it's not easy.
That. Yeah, absolutely.
Yeah. Thanks.
So then next we have Edie coming to tell us about what B Public Prefab does.
Thanks, Scott. Let's please move the slide. Look at that one. Thank you. Yeah, it's hard to switch into talking. I've been having such a good time listening to Jan and to Mariana. Great to be here. Be Public is a little bit different in the space, and I love this slide. I talk a lot about the impetus for change and jumping into a new venture, and certainly having kids and realizing that they're way ahead of adopting and realizing that we need to fix things. And man, if we don't hurry up, we're going to be in big trouble. My kids will never come visit me in the old folks' home if I don't start helping, certainly in the environment, but also job creation and really making change. We talked before we got started officially on this presentation around the urgency, and I like to bring it up. There is truly a housing crisis at the same time that we have a real climate crisis, and the crux of the problem is if we meet the housing demand without real meaningful change, we're creating a larger problem than we already have in the environment. So great, amazing talking around not only prefab, but around passive house, and Be Public really believes that passive house and high performance and building science is the way forward. We're totally committed to supporting the community of passive house, but also greater adoption for high performance, comfortable, low energy homes for everyone. So meeting the housing need across the country, at the same time of really addressing the failures in how we're building now and quickly adopting a new system of building. So Scott, you can jump to the next slide. And really, we're all about, this is an amazing community that's on this conversation today. There's a large movement afoot and has been in the US for over 10 years now to high performance. It's a very supportive, collaborative group of folks. It's not nearly enough. We really need to call more people into this change. Mariana and EMU does an amazing job of training and bringing people into building science and handing out the Kool-Aid right and left. But really, in order to make meaningful change, we need to create systems for faster adoption. And so we have a kit of parts, if you will, of 86 components, Lego-like components for Passive House construction. This panelized system is very understandable in both design and construction. But the point is that any builder should have accessibility. Any client for a home should have accessibility to better building methods, better materials. And we are working with other architects. I'll put it in the chat today. We weekly do open technical onboardings for builders, for architects, for designers, for engineers to start playing with our kit of parts and learning how to design with panelized system in mind. We also, quickly take off of people's drafting tables and their Revit files, their building envelopes, and we will build 3D models out of our library of components and kick back estimates almost immediately. My staff, our team would hate me saying that, but almost immediately, so that high performance, low energy, carbon sequestering can be on the table from day one, even from a schematic stage of design or imagining a project, rather than at the very end of a project when time has been burnt, budgets have been burnt. So it really is a collaborative with builders, with developers. Thank you, Scott. Yeah, let's go to that next one because it's a perfect example of what we do. So when people ask us to take a look at their projects, this is a great example. It starts all the way on the left to a single panel, the solo panel with a nice window opening in it, to a very simple ADU form in our panels, including the floor panels, to a more complex single family home, onto multifamily projects. And I love that Barbie pink in the 3D SketchUp models, but the 3D in the pink is what is not BPublic. So we're starting to share with our architects or developers, where does a hybrid approach come into play? Where does that foundation need to be something else? And we need to start looking at those interactions with site built, with custom prefab and a panelized set. So this is along the back of that. You can see those are the components themselves. Our SketchUp models are downloadable on our website. You're welcome to pull them down and start playing with them. But we offer technical assistance to start learning to build, it's a grid. It's not for every project, but we're squarely focused on housing creation and making as many projects as we can be high performance, low energy, and built. See, look at that. Perfect timing, Scott. You're amazing. You can see right on there, those are the SKUs, those are the panels. So once we build a 3D model of a project, we just pull that takeoff and it's component-based pricing. And so it can be iterative. So a client can look at that and add to it and subtract and be appropriate to what they need for building, which is great for infill projects or ADUs, but it also can expand up to those multifamily projects. So we're really working across, I would love to say, I want to make Mariana smile, climate zones 2 through 8. How'd I do? 2 through 8. And we have, 3 different R values to be appropriate to the site. But as Yan pointed out, there are a lot of places where it is difficult to build. It's a difficult time to build already because of the labor shortages and costs. But when you have a very short building envelope in terms of seasons, or you have really not nice neighbors, getting up and weathered in a week or two has huge advantages, as well as the ability to allow builders to, increase their capacity for how many homes they can build in a year. And so that same envelope that we just looked at, that simple form, can be decorated to be appropriate across regions. And it really allows for the style, for the architecture to come forward and performance to be baked in. So we've optimized so that you're always getting a thermal bridge free, vapor open, totally weathered in, airtight envelope. And how you decorate it, how you choose to live within that space is really up to the client and appropriate to the site. And I think, yeah, so we covered a lot of this. There's a lot that's wrong in how we're building, how we've built, and there's a lot of room for improvement. We support wholeheartedly the movement to high performance and passive houses the way through. But we also are looking at the embodied carbon of the materials we use to achieve that high performance, that we really need to address the embodied carbon of the materials. So I'm very proud to say our panels are petroleum free. They are fully insulated with dense packed cellulose, so it's 86% recycled newsprint. And as we say goodbye to our poor newspapers that are all going online, that will probably shift to something like Amazon boxes, so cardboard as cellulose or even hemp. But the point is that we're looking for things that are carbon sequestering, that will truly be resilient long-term, and that the investment that we make in our buildings are permanent, that it does not require bells and whistles, it really just requires physics.
Thank you, Edie, for that amazing representation of your company. So last but not least, we will dive into elevated design build with David.
All right, yeah, thanks for having me, Scott and Audrey, and happy to be here. Thanks everyone for coming into this Zoom call. So elevated design build, our company, we specialize in timber frame buildings in particular. We are a residential general contractor here in Northern Colorado. And, beyond timber framing, one of the focuses that we utilize in our buildings is energy efficiency and green building. And with that comes, I believe, the panelization effort. For a long time, structural insulated panels have been the kind of standard when it comes to panelization on a timber frame building. So we've done a lot of structural insulated panel buildings, as is evidenced here in these slides. So with regards to prefabrication, as Jan kind of alluded to, timber framing is kind of one of the maybe original prefabricated building components. It's been around for centuries as a building technique. At Elevated, we have a 6,000 square foot shop in Fort Collins where we'll bring the freshly milled timbers in. We'll do all the layout by hand. We'll cut the joinery then using hand and power tools. We'll actually pre-fit all the components in our shop so we can make sure everything looks nice and all the critical building dimensions are intact. And then we'll put it on a truck in the order that it's going to be installed and go out to site. And in a matter of days, we can have a structural frame standing. Some of these pictures here, the picture on the upper left shows one of our local manufacturers of structural insulated panels we're using in this project, going up on top of some timber rafters there. And on the bottom left, there's some smaller, it's a smaller addition that we were doing using these panels. And as everyone here has alluded to, the big benefit for the prefabrication in our world is the kind of speed in which we can get these structures up and dried in. In northern Colorado here, we do a lot of projects in the mountains, which means shorter building seasons. So the quicker that we can kind of get that structure up and dried in, the faster the mechanicals can go in and the quicker we can get things kind of buttoned up before the snow starts flying again. Yeah, that's kind of the big benefit in my mind. Besides, of course, you know, I'm a wood guy. I think timber framing has a certain aesthetic appeal. There's something about exposed structure that kind of brings a sense of awe, but also a sense of comfort to the people that are in the buildings. They kind of instinctively know how the shelter is being created over their head. And I think that's something that's pretty special within a building here. So these are some pictures of the kind of timber frame process and us kind of cutting some joinery, stacking it in the shop, and then some raising pictures as well.
Cool.
So,
Thank you, David.
Yeah.
For the sake of time, I'm going to hop into some of our questions. So now you guys have heard a lot about from the building community, you know, why these different people are doing what they're doing and the benefits of prefab and offsite construction. So we want to switch it over a little bit. We're obviously, we got to get the homeowner on board too, right? And the construction industry can think one thing, but the consumer in the end is going to be the deciding factor of how many of these type of homes are built. So I wanted to open up, what benefits does your system bring to the homeowner, and why would they want it? Edie, we could start with you.
Thanks, Scott. Yeah, and I talked about this a little bit, but we're geared towards either removing barriers or reducing the barriers. And there are very few solutions or options for homeowners around high performance. We were just having a conversation with a homeowner today of really not being able to do the research online and find better systems and really do all that evaluation for themselves and their desire for the performance of their project, whether it's, you know, adding solar or adding heat pumps, but people are really doing that research, but they're not able to find a local support to get it done, to find the trades to do it. So for us, working with homeowners, one of the ways that we try and remove those barriers is one, just education and support. We really are happy to kind of talk to anybody about where they are in their journey, whether they're looking for land or they've come up against, they can't find a builder close and they want to find somebody within the network who would know how to do high performance. So just being open and available, but we also have on-staff architects and we have standard home plans that we work with homeowners to customize for their site. And when you say customize, some people think, oh, like fancier tile or, you know, what are you going to do there? For us, that really means being appropriate to the site. That maybe they don't need as big a footprint. They really want a smaller building. That's great. We can adjust and shrink the building in an 8-foot increment to just what they want. But it also means shuffling the windows and doors around that footprint so it's appropriate to the site so that you're really getting the privacy you want or really taking advantage of the view, but that every single site needs to be custom. And so it's not cookie cutter for us. There's some pieces around it that were sort of non-negotiable, which is the performance and giving options for even, you know, less concrete going to post and beam if it's appropriate. But we're ultimately designing homes for people so that they're ready to go get a builder, go get a permit and move forward. So we're kind of, you know, doing, I don't want to say turnkey, but we're helping provide the designs. We're allowing people to work with builders and then of course purchase the panel system that gets delivered to site, so that they can build to high performance.
Mariana, when you are doing the EMU systems courses and you have the builders coming in and learning this passive house certification, what are they then going and telling the homeowners that they work with?
Yeah, it's a huge topic because first thing people say is, "Ooh, passive house, that's going to cost me a lot, right? Why would I do that?" You know, and the value proposition for passive house is, and this is what I was, when I was on that slide thinking of what's the other thing I wanted to mention, it's the biggest thing that I completely forgot to mention. But one of the reasons, you know, the way we work with prefab and modular players in the field is under this context of us helping them reach the passive house certification level. And why is that? Because if we can help them do that, if we can help them pre-certify their components and design them in a way that are compatible with passive house certified buildings, the biggest advantage to the homeowner is that the passive house standard really addresses more than energy efficiency. The biggest value propositions to the homeowners from passive is indoor air quality, thermal comfort, being able to live in a space that's not dusty and noisy and has continuous fresh air ventilated through the space. And all of these panels that are going for, any component really can go for passive house pre-certification. There's an entire component database of products that have gone through this modeling process and certification process. And it's just one step toward removing that hurdle, like Edie was talking about. It's unreasonable to expect builders offsite or onsite to, you know, spend their weekends doing building science modeling. It's a completely complicated world in and of itself. And now that we have high performance products, each of those products is incredibly confusing. And if you're the homeowner and you're trying to understand how smart vapor retarders work, and you're just like, I just want my house to be clean, you know, this is a way that we as an industry can standardize that a little bit more to a standard that is kind of mutually agreed upon and recognized from a science basis, and then offer that to the homeowner in a way that's kind of measurable. It's something resilient, something durable. Another aspect is that homeowners, you know, the demographic of the American homeowner is shifting quite a bit. And I don't know if that's really talked about enough. You know, the statistics on how long people stay in their homes used to be, you know, even now when we ask our builder students, they'll say, oh, is it like 5-7 years? No, it's now up to 13 years. And that was honestly a statistic from several years ago from the North American Home Builders Association. It's probably more than that now, especially if you start to consider the effect of this past year. People are not moving as much because you know, they're bunkering down a little bit more. There's a lot more emphasis on resiliency. We've got wildfires raging everywhere. There's a lot more attention towards how your indoor air quality is, how you can filter that. So things like prefab panels, but also other components that are already certified to a level that will help you achieve that standard. So much help for the homeowner.
Thank you, Mariana. Jan, what are you seeing up there with the homeowners that you were working with?
I would say the biggest thing that we can bring to the table would be a level of predictability. So obviously it's an unpredictable time for everybody, and building a house is a very unpredictable thing. But I think one of the benefits that people do see is that they can have a foundation built by someone local that they might know. Hopefully they know. Sometimes it's themselves. And a foundation itself is inherently robust due to its, you know, its materials. So you can build something that's robust and that can stand the test of time and handle the weather, and then you can have somebody else take a big chunk of risky scope, you know, walls and insulation and tapes and membranes and framing and sheathing and all these things that don't really like to get wet and don't really like to be outside. And they can give that scope to us, and we take care of all the planning, all the buying, storing, building, storing again, shipping, and install. So I think people find comfort in that it's a large item that they can guarantee that is being built by people who only do this. You know, it's everything we do, so we have to do it well, and we take a lot of pride in our work in order, you know, to make ourselves feel good, but also to survive. So it's yeah, it's just probably, you know, I can't speak for the homeowners, but I think that it brings a certain level of predictability to a very uncertain task in a very uncertain time.
Predictability, unified standards, two of the phrases that are really popular in these conversations, and two of the things that construction as of now does not really have, which is why we're having these conversations. So David, we'll close with you on what you're seeing from homeowners when it comes to the panels that you do.
He's like answering
All right,
things.
trying to figure out the unmute button. So yeah, I mean, you know, I think it's been talked about a lot how the speed of which these can go up is a big benefit to people. Jan talked about the sequencing and being able to kind of be fabricating the panels or the timber components in the shop while the foundation is going in or while site work is happening. Another benefit in terms of the timber frame aspect when we're talking about energy efficiency and high performance is that the enclosure itself does not need as much lumber in it when using heavy timber construction, because the timber frame is what's kind of carrying a lot of the roof load or a lot of the structural loads as well. So the timber framing in particular, you know, lends itself great to natural wall systems. If we're talking about like straw bale walls where we're looking for the walls to provide a lot of insulation and the timber can kind of carry the roof loads and stuff like that. Generally, there'd be less lumber in the wall enclosure itself, reducing thermal bridging, increasing our value of the wall system as a whole with that timber roof system. So let's see. Yeah, also, you know, the prefabrication in the shop, it does reduce the amount of waste generated on site, which I think is something that, you know, I believe is a value. And in terms of the homeowners, the less time spent on site with the carpentry crew or the less waste generated can help cut down on those logistical costs. You know, the dumpster doesn't need to be on site for 8 months. It's only there for 2 months. Or, you know, the porta-john, for instance, or whatever. The longer a project goes on, the longer those overhead and logistical costs are prolonged throughout the project. So shortening that time frame of the actual build is a benefit. The less waste produced in the shop, or, you know, the offcuts from our timbers. A lot of times we just give them to our homeowners to help heat the house, or we have a free bin out in front of our shop. So a lot of the timber waste or the offcuts from the joinery that we're cutting goes to, you know, good use in helping heat people's homes and stuff. With the panelized wall systems, you can use scraps a lot more effectively, or rather plan out the walls and the cuts and make most efficient use of those building materials in the shop. Whereas out on site, whether you're in the cold or here in Colorado, it gets either really cold or really hot. So you're just trying to get it done and kind of whipping through things as quickly as you can. So there's a number of benefits to the homeowners.
Yeah, I think Edie wanted to hop in as well and talk on David's points.
Yeah, I mean, I think what's really extraordinary about this panel is I love that it's craftsmanship forward. I mean, I feel like I talk a lot with people who are confused about modular versus prefab and what it all means. There are the dogs. But that this is about ensuring the craftsmanship and the craftspeople are you know, in shop and protected and have a stable, you know, work environment and some pride in their work, rather than solving it with technology. And I would, you know, for our system, and I think what Ian and Mariana and certainly David are talking about is pairing really old world craftsmanship with cutting edge materials, like the air barriers that are available now and the weather barriers. You know, it's like the Gore-Tex, like we're building houses like Patagonia jackets right now. Like they're really intended to last forever and be resilient. But I love that we're talking about solutions based on elevating how things are built well, rather than skipping the craftsmanship. So and David, your work is so beautiful. I just wanted to call that back out to your slides. I mean, it's just so fun to see things coming together and built, you know, the puzzle pieces that you're making create beautiful homes. It's just really cool to honor that today on this panel.
I think those were all great points, Edie, and you mentioned materials in there and building buildings like Patagonia jackets. I like that. I like that analogy. And so now we're moving into talking about building materials and what building materials are compatible with prefab and offsite construction methods, then obviously with the high performance aspect of Passive House. So Ian, would you like to go first here and talk about the materials?
Sure. So I guess we have, yeah, we don't have too many troubles, you know, with building inspectors and people like that. In the past, we had a little bit of a just do it and beg forgiveness kind of situation, but I don't think, you know, we live in a unique environment, you know, rural British Columbia. Maybe you could get away with things a little bit more than some places. I think, for example, you know, the Denver area is sort of known for being fairly picky in the building inspection departments, and lots of other American cities are, of course, as well. So earlier in the day when we were importing wood fiber board from Europe back in 2013, to maybe even before that, 2010 or 11, maybe Rain can tell me, or not, or something, but that was a bit of a struggle. You know, we're trying to convince local building officials that the vapor barrier should be or can be a sheathing product that's taped, you know, and then trying to explain that we're not going to use poly, you know. So definitely we've had our hurdles, but just, yeah, kind of pushed on through, you know, a little bit of educating the local building inspectors, and probably really lucky that, you know, we know them by name and you know, have relationships with them. But whether it's, you know, maybe playing sports or the kids know each other or whatever it is. But as time has moved on, it has become a little bit more tricky. And one of the benefits of our system would be that it's not that different from standard construction. You know, we do have an open structural framing layer, and then there's the outer I-joist framing. So we're not trying to have them trust us about everything. You know, at least the framing is visible, and we've been able to get by with photo documentation of sheathing and shear nailing patterns, and just kind of getting ahead of it and maybe asking them what they want to see instead of reacting and saying, like, you know, oh crap, what did you want to see? You know, and here's a fuzzy picture of my foot. But it's so far so good. You know, the education is working, and building inspectors are now a part of it finally. Now soon we're going to need appraisers to be on board, but you know, I think that for us it's just, yeah, we've just become a little tighter with how we plan things, how we document things, how our shop drawings are relayed, and you know, the regularity of information being passed through. So personally, not too many troubles lately.
Thank you, Jan, and that was a great answer, because you actually combined our two questions here on materials and then on the building department and state department approvals. So we'll probably have to combine those questions since we are running out of time here. David, definitely wanted to bring you in on the materials discussion, and if you have anything to note about approval as well or not, but obviously lumber is at an all-time high. What has your experience been like with the materials that you've used with the panels?
Yeah, so I would just say in general with prefabricated systems, the upfront planning is kind of the most important part. And how I'd speak to that in terms of the materials is talking to your subcontractors or your tradespeople about how their systems are going to integrate into the structure or the panelized system that you're using. our systems in particular, timber framing is nothing crazy. It's been around a long time. It's compatible with a lot of different things, as I kind of alluded to earlier as well, that it's a great system when your goal is to use natural materials for your wall systems. You're not relying on your wall to provide structural capacity besides maybe some shear or lateral resistance in addition to what the timbers can hold. But with my experience with the SIP panels in particular, as Jan was saying, trying to get people to make decisions up front. And with the SIPs, an electrical and lighting plan is of utmost importance, because they're running the chases and everything is being put inside of the panels for all the wiring, as they're being fabricated. And it is very, very difficult to change things in the field. With the SIPs, I honestly don't love the polyurethane foams, or even just the EPS is better. It's still a petrochemical product, and I really love the foam-free panels, or the kind of ban the can movement that's going on right now. I think with a lot of the high performance systems, they're moving those mechanical chases and those where you're running your electrical wires and everything kind of inside the air barrier envelope, which makes it easier for the electrician to run wires where he needs to, or where they can set boxes, maybe where the homeowner wants to move one a couple feet, or whatever. So
then yeah, awesome. And then Mariana, specifically on Jan just mentioned that the high performance aspect. Obviously, all of the products that you guys work with, the EMU systems, all the building materials are super high performance. Can you talk about those a little bit?
Yeah, sure. So the slide you're showing is a list of some of the manufacturers who donate to our training. Our training is brand neutral, so we only take product and material donation, which is great, because then you get to play with all of these different things. I think, the question was about kind of what products are compatible with this type of construction. And, the short answer is like anything, if you detail it right and design it right. Right. So I think the more pertinent question is kind of, how are you verifying the compatibility? And that's where I come back to that notion of virtual prototyping as really the way to do that. One of the comparisons I make sometimes is the aerospace industry. They're not like building a plane, flying it and seeing if it crashes or not, then building another one, which is kind of what we're doing in construction. We're just kind of seeing how that goes in a one-off situation and then see how it operates. And whereas we can handle a lot more virtual prototyping and dynamic simulation than I think most construction professionals understand is possible. And especially when you've got, these pre-designed components like panels, you on the manufacturer side, you can put in all of that work towards understanding how it performs building science wise. And then on a project specific basis, you then just plug in that data to the whole entire project. It makes it a whole lot easier on the building science side of things to start modeling that stuff. In the passive house world, and I'll pick up a little bit of your number 4 question too, Scott, in the passive house world, the biggest, things I guess that come up are like, flat unvented roof is always an issue with code officials, and submitting a PHPP instead of a manual J. I'd say those are kind of the only 2 things we run into. But if you are approaching it from a building science perspective, we have reports and models that show that performs a certain way. We rely on the simulating to be able to show that. Then we rely on putting data sensors into some of our existing projects to prove that it's actually performing the way it was modeled. And that's a whole other topic that we can get into and go down the rabbit hole on, but it's called the performance gap. And there is typically a performance gap between what you model and what it actually performs like. One of the reasons we love the passive standard as a benchmark is that performance gap is a lot lower than with other kind of vaguer ways of approaching it.
So Edie, you obviously showed us at the beginning of the panel that you guys do a lot of the modeling that Mariana was just talking about. Do you want to bring us home on the question on materials?
Yeah, it's actually a great question. You know, we designed this system with the intent for Passive House standard. It is not a certified product because we're offsite. Technically, everything is a set of plans, and it is an individual project utilizing our shop drawings. And when we model, and I just sent Mariana a note, we're actually not offering modeling services. So if you were going to certify, we don't do that. We do that with partners. Fortunately, we're busy enough with what we're doing in designing for projects and onboarding architects and builders. And there are plenty of people out in the field who are amazing at modeling and working through the PHPP. That said, when we quote our R values, that's coming through the PHPP. That's not just counting up the materials and saying that's what our R value is. But when we talk about modeling, it really is playing with those Lego-like blocks and showing and describing how this building will go together. And we use that to onboard the builders on a project. You know, this is not a plug and play, one day, you know, designed, closed, and built process, right? We're in this for the long haul until the project is up and completed. So working with the builders to onboard them, explaining to the clients, no, that opening is not ADA. Okay, you want to make that an ADA door? Great, we'll expand that door. So we use the models really to show people what it is the structure is going to be. And then we start applying those finishes and decorating the building. So we use modeling in a different way. But yes, the buildings are modeled, but not necessarily by us for projects. Sorry.
Thank you, Edie. And so we will skip question 4 just for the sake of time and move into question 5. And what I want to get with here, guys, is obviously this is a very revolutionary time in construction where all of these new systems are really rising in popularity, and there is, I think, more of a need now than ever with the climate crisis, with the skilled labor shortage, with everything that you guys just talked about on this amazing panel. So really want to thank you guys so much for coming together and sharing your insight with us. And to close us off, I would love to dive in to some of your systems highlight projects and just talk really quickly about some successes that they brought and what that kind of means for the industry. And our first one is David.
Yeah, thank you, Scott, once again, and everyone who's involved here. So what's on the screen now is a large project that my crew and team spent the past 2.5 years on. This is not a residence, as might be obvious from some of the pictures, but it's, so this is a clubhouse for the new Players Championship course, golf course at Heron Lakes here in Berthoud, Colorado. This was a really fun one for us to hang our hat on. There's a lot of big spans that we need to accomplish with the timber. We worked very closely with the architects and structural engineers to accommodate the mortise and tenon joinery. So we did use traditional joinery in just about all of these structures here, which is not very common in commercial construction these days. A lot of times they just want big wood in the air and get it up and get it done. But you know, the client and the architects, you know, this is what they wanted to convey to their patrons and what they wanted this project to mean, and incorporate that level of craftsmanship and that, again, sense of kind of like awe of the structure over your head being something tangible that you can understand. So yeah, this was a real fun one for us. Took a lot of time and resources. Then here's just kind of the other end of the spectrum, a small timber frame house in northern Colorado here. This same house, you know, in all of our designs, and in that last picture, actually, Jan, I can explain a little bit more about the design process quickly, but we're building here on the Front Range where everyone wants views of the mountains. In terms of passive solar design, western sun is often the most harsh, and you're going to overheat your building. So we like to design big porches and big overhangs on the western facades of our buildings. In this case, we have a nice covered porch there to hang out and watch the sunsets and watch the storms roll in over the mountains. So that's kind of incorporating a little bit of the passive solar and the design aspect along with the craftsmanship of the timber frame there.
And now,
My turn.
yeah.
Yeah, so I don't think I shared too many photos of this one project I'll discuss with you, but on the first page of the slides, there's a little photo of the church project that we built up in Fort St. John, British Columbia, on the Doig River First Nation. It's on the first. Can you zoom to the first page of the slide? Anyway, it's yeah, almost, yeah. So it's a little photo there. So this project was a so the reason I think it's a highlight is like I described a little bit earlier, it's recently been certified FIAS Passive House certification. So I know that the contractor worked really hard to get it there, and we were really proud of it because it was a big old thing to build, and it took a serious amount of time and effort. And when we did the blower door test, it surprised the hell out of us, and we got, I think it was 0.09 is what it tested at. So it was pretty awesome, and we're really proud of it. It tested us in a lot of ways, especially the installation. You know, trying to, those arches, those timber frame arches, they're glulam. It's kind of hard to tell, but they're 45 feet tall, and in order to, you know, build a building that's 90 feet long and 45 feet tall and arches on both sides, those are, I think, I can't really remember what the spacing is, but it's 10 feet on center, something like that. And it has 3 panels that go up it's 60-degree slope, 3 panels that go up, and then the vertical panel there forming the wall. And it was just a ton of integration between, you know, me doing the design and our shop crew building panels, and then a really tough winter install, which was guaranteed to us to not be a winter install. It was going to be a summer install, but it actually, everything panned out, and we installed that in January and February up north of Fort St. John, and it really was minus 35 Celsius a lot. And you know, there were definitely times when we would drive to the site in the morning and just pray that the crane wouldn't start, and it did. It always did. And literally, you drop a tool out of your pouch and it would just shatter. So there was a really tough crew, and we don't look back on that too often, but when we do, we feel very proud of the fact that we built this cool project for some really great people who really wanted that church.
Absolutely. Thank you, Jan. Excuse me while I zip back through here. Edie.
Scott, that was really impressive. Really
Thank you.
impressive clicking. You know, this is a great example of a standard plan. And I'll just take the moment to explain, you know, traditional floor plan on the left, and then divided into the panels on the right. And then in the lower quadrant, it's the building missing its top panels. You know, this is a really sweet house, but I would love to just highlight that, you know, the projects that we have under development with partners goes from 500 square foot ADUs to a large multifamily. We're working with one developer where it is potentially 60 homes as single family, as well as working on infill inner city solutions for single family homes, as well as row houses on the East Coast. So I think what's most exciting is the range of people that we're working with. I think it's been a blessing of COVID that Zoom has allowed us straight into the offices of people who are looking for solutions. We feel very well understood in the industry, where we feel sometimes very ahead, forward thinking. But across the board, people are really excited about this movement. And I want to say this movement because it's everybody who's on this call, listening as well as speaking. And I always like highlighting, we have an amazing project here in New Mexico that is a co-housing development. And when we talk about changing minds and people making decisions together, that a community of, I think at the time it was 22 or 25 owners in this LLC of a co-housing all collaboratively chose together to build to Passive House standard, to build with panels, and to spend a little bit extra to get away from code and really drop their carbon footprint. And I think everyone knows that every project gets challenging and there's always a budget. But when a community comes together to make great decisions, we love co-housing, and these intentional communities really are looking forward for many generations. They're making decisions for 7 generations out, and acting really as stewards and ancestors to their own communities. So I'm just really excited at the range of who we're working with, but also the intention of developers, builders, and homeowners to really want to live in a quality environment and have real resiliency. So thanks, Scott.
Thank you. And we will close it off with just learning a little bit more about Mariana's system with EMU systems and what kind of projects that led to.
Yeah, you know, we kind of have our fingers in lots of different projects since we work primarily with the builders and manufacturers on them and not straight with the homeowners. But I would say the most influential, one of the more influential or kind of important projects for us was the first of our pilot program, simply because it was directed with the homeowner, and the homeowner then came down the rabbit hole with us and now works with us full time, is now our builder liaison who helps other builders get this stuff done. And I think to that point, we come back to the education factor on this. Like, the most important thing that we have seen is educating people, making people aware of what the options are, and helping upskill the workforce and bring more knowledge to folks, because it can then change their entire path towards this. But, you know, one of our company mission is to kind of close the gap between mainstream architecture or mainstream construction and what's happening in advanced building science and standardized systems. And the education and the workshop and how we do our course is really our way to start that conversation with people and get traditional builders thinking about going off-site and what it would take to get there in Passive House, you know, in the Passive House mentality. So the slide he's got showing right now is just kind of a little sections of our passive pod. And I think I mentioned before, you know, in each of the different sides of it, we kind of try to address certain things from the curriculum to help them learn about building science. You can go ahead to the next. Yeah, and that's what it looks like. It's a rough, you know, it's a box. It's we have if you'll see in that photo on the far left, you'll see that one of the windows in that pod on the far left is a little bit different. It's got a lot more glazing to it, a lot less frame to it. So our consistent volume, every pod that we build has a consistent interior volume, and the students all build their passive pods in the workshop. That one on the far left, we had our intern build, and it is a code pod, and that is built to the 2018 IECC code. And so one of the fun bits at the end of workshop is we, you know, really drive it home of why do we keep talking about passive house? Why do we care about building science in the context of all of this? And the pods really show that. So we run a few tests on them. We do kind of a qualitative thermal imaging. We get out our thermal imaging camera and have them look at some of the thermal bridges on the code pod and the absence, hopefully, of them on the passive pods. And we get out smoke tests, and all the teams are trying to spot the leaks on each other's pods, which gets a little competitive sometimes. And then the last thing we do is a resiliency test, and we leave the pods out overnight. In Colorado, it's great because in the winter, a lot of times they get snowed on overnight, and really you can start to see the difference of what passive can offer to building technology. And that is that it retains the heat for a longer period of time with no additional heat put into it. And so these graphs are just showing the big gap between the top lines in both of those graphs are all of the students' passive pods, and that one that is falling rapidly down to freezing, that's the code pod. And and so again, it comes back to the why of this. Why are we trying to standardize, and why are we trying to simplify with offsite and modular? And the reason, I think, is because we're trying to make it simple and accessible for people to build better, and to come back to that concept of craft, and both from the homeowner perspective, but also from the employee perspective, which was mentioned a lot in chat about the health of the employees, that are working in these offsite factories is so much better. Hopefully we can then convince some of these young people to come back to the construction industry, and, those jobs can become sexier to them again. And we need that. And so, and so for us, it's the educational arm that gets us there. But we want to do that in a way that supports all of these standardization efforts. So yeah, that's all. Thanks.
Thank you, Mariana. And so very quickly, as we wrap up here, I just have one interesting question that's not something we covered. If any of the four of you have an opinion on this, it's if any builders are having trouble with getting prefab components to the job site via truck trailer due to being basically overcomplicated. So do any of the four of you want to answer on any troubles builders have moving around the prefab parts to projects?
Maybe was the question, is it difficult? Like, are there troubles moving prefab?
Yeah, the question
components?
was, is it difficult, or do people have trouble?
Yes and no, I guess. It can be quite difficult moving. That's when we started building inside, we were really obsessed with building the buildup of the walls, the buildup of the panels, all the different materials that we're going to use. Where do we find all this stuff? And then we started building panels, and then we're like, oh crap, well, now we've got to move these things, and it was really funny that the simplest thing, actually moving these things that often are 2,000 pounds, 6,000 pounds, that's the struggle, getting the project out of the shop and getting it stored safely. It's a ton of value that you're often moving out of the shop environment, and you're covering, and you're trying to keep it level. And you're also trying to put it in a place that's going to be easy to load, and then it's going to wobble down the road for 2 hours or 20 hours. So moving the panels is a huge struggle. I wouldn't say it's like we certainly haven't found anything to be impossible. It's just that it needs to be done thoughtfully by people, I guess, that have experience with their own their own product. I don't think we'd really want to send our panels to a contractor anywhere else and say, hey, take these 80 things that weigh 2,000 pounds and put them over there, and then put them up. That's not something we're comfortable with yet. And with pre-designed panels, that can become attainable. I definitely think that pre-designed parts, pre-designed panels can be coordinated with someone who didn't build them, and that can be done successfully. But with our custom panels, there's just a ton of little things to know about them that we still want to be an integral part of the shipping and the offloading, staging, install process. So we're not yet comfortable with giving that to somebody else. So on a positive side, if anyone was to buy panels from us, then you get us too. So we'll take care of that for you. But yes, I would say it's not to be underestimated. Moving anything very heavy anywhere is difficult.
Yeah, I think that was a really solid answer. And one thing I just also want to point out as we end this, as we looked at all of these project guys, like clearly they're not just simple architecturally. So that is another stereotype that the industry is facing, is that there needs to be an architectural simplicity to everything that's prefab, anything that's offsite, which is just clearly not true. It's just a little harder to make it good, as Jan was just describing. So thank you all so much for attending this panel and for all of your amazing insights. Once again, this panel was put on by offsitedirt.com. So you can go to offsitedirt.com and check out all the latest updates, news, and trends on offsite construction. We have one of these panels every month. So for the remainder of the year, we'll be having these sort of panels always on a different topic. If you want to be a part of one of these panels in the future, you can email that email at the bottom. But again, just want to thank you for, as Mariana said, participating in this panel about panels.
I'm a
Thank you.
nerd.
What a nerd.
God, it's horrible.
Awesome.
Thank you,
Thanks,
Scott, for
everyone.
facilitating.
Yes, thank you.
Thank you guys. That was great.
Bye, everybody.
Thanks, everyone.
Bye,
Cheers.
everyone. Have a good rest of your day.
You too.